When we're writing the equation, we can leave x as x, right?
Well, x is a variable. You need to leave it as x for the final equation.
Okay.
Yeah.
I know.
Guys, we got 4 answers in. It's been 8 minutes. We need to get an answer in there. We're going to go over it. Put what you have into the calculator at this point.
Equals 3 over 2 for 8 minus 3. Outside 3, 6 minus.
That and everything in lesson 4 of the textbook. All right, I've got 6. I need answers in there.
What is that?
$30 more seconds to get an answer in. I'm still only at 6 answers submitted. Hey, Destiny. I'm up to 8. Make sure that you submit your answers. Key Anthony, have you put your answer into the calculator yet? Put something in at this point so you get credit for having the bell ringer complete. Okay, while those people are getting their answers in to wrap that up, I'm going to let them keep typing so they get some credit. We're going to look at this problem together. I'm going to go ahead and say this really quickly. We're going to have the understanding check in a second. But to be honest with y'all, I'm going to ask for a little bit of grace. I already feel that I'm a little frustrated and short, and that's not necessarily just y'all's fault. It was a frustrating day yesterday as a teacher. Just didn't feel like I was effective, and that sucks because I want to be a good teacher all the time, and it's not always realistic. And then I just feel like I'm wicked behind on grading and other things. So, as I said, I am a little frustrated. I apologize ahead of time if I get short with you. That's not what I want to be, but I think we all know that some days are better than others. And so there's that. But let's look at this problem together to help get ready for the understanding check. If we're trying to write a quadratic equation, what do we need to do first?
Write the equation out first so we can start substituting.
Right, we need to write out the equation first to figure out where I can start substituting values in. If you don't write that equation out first, you're shooting yourself in the foot. So what equation should I be using here?
Factor?
Oh, which one is it?
Well, you can use both. But
Oh.
if you have a vertex, I'd rather use vertex.
Okay, so I want y'all to know, like, one, how do I know that I can use factored form for this one?
Because we have roots.
We have roots. You would want to note that 1 comma 0, so R1 is equal to 1. And then I have 5 comma 0, so R2 is equal to 5. I can use factored form for this problem. But I also do have the vertex here. That vertex I think was 3 comma negative 6, is that right? And so 1, 2, 3, 4, 5, 6. This negative 6.67 is at the very bottom, but just count it to check. Does that make sense? Okay. So you need to be intentional about your points there. I know some people might have been tempted to choose maybe these. I don't know for sure. I think that that's a 0 comma 7, but do I know that for sure? No. You could have made a table to find that rate of change and figure out what it would have been, but we have the points we need here. So regardless though, let's look at it both ways because it should give us the same answer. If I want factored form, what's the next thing I'm going to do?
Right out of
You're
the
gonna
factory
go, I
form.
would just go ahead and plug in what R1 and R2.
See, I wouldn't quite go that step because I haven't written out the equation yet.
Oh, okay.
Right, I would write out that equation. Then I might substitute in R1 and R2. I might go ahead and substitute everything in. Notice I've already labeled R1, I've already labeled R2, so if you want to do this extra step here, it will help you in the future. But I probably would have gone straight to this step. At this point, I need an X and I need a Y. Remember, f of X is just the output, that's my Y value. So what X and Y do I already have on the graph?
The vertex.
The vertex, 3 and -6. So what's going to be substituted in for f of X? -6 is equal to A times
3 minus 1.
3 minus 1,
3 minus 5.
3 minus 5. Now I only have one variable and I can solve for A. -6 is equal to A times 2 times -2. -6 is equal to A times -4. Now what?
Divide by -1 right now.
Okay, I can divide by -4. One thing I'm going to caution you because, and again, I saw this issue on the linear and exponential understanding check. What's another way to write that division by -4? Multiplying
By reciprocal.
by the reciprocal 1,
Over
not over, divided by -4. Remember, I want you to think about that as that 1 divided by -4 because it's still showing that division, and that's going to help you when you start writing equations or when you write equations of exponential functions. We're going to get some more practice with that because I saw that being a struggle so far in the understanding check. So, whenever you have a number and it's reciprocal, it always creates a 1, right? Because again, that's -4 divided by -4, and -6 divided by -4 is 3 halves equals A. So now I have A, I have R1, and I have R2, right? And again, I would have personally gone from this top equation down to this one, because if you've labeled R1, R2, and A, you can easily write the equation. F of X is my output. Hudson, I think, was the one who asked, can we keep the X? You have to keep the X for the equation because you need an input, X minus 1 times X minus 5. What are your questions about writing that factored form? So we need to, if we're going to go with factored form, we need to be able to identify roots, we need to be able to substitute in values.
Is it still
for
okay
X
that
and
we
Y?
divide by -4?
Look, I got 2 questions, hold on one second. Hudson did start first, say again.
Is it okay that we still divide by -4? Because I don't know how to use reciprocal.
Let's talk about that really quickly. Any number is understood to be divided by what? All the reciprocal is the fraction flipped. That's all the reciprocal is. And I understand that you're saying, like, I don't know how to do that, but you need to start training yourself to do that because it's going to help you. If you say, hey, I'm dividing by 4, that means you're multiplying by 1 to not change it, and then dividing by -4, right? That you need to start training yourself to do that. It's going to help you long term. It'll pay off a lot. I won't count it against you, but I'm going to always use that reciprocal to help you build that better. Elijah, what was your question?
You said we gotta know the roots, we gotta know the vertex, right?
Well, you didn't have to know the vertex only, it just had to be any point using factored form, right? You just had to know another point. We had the vertex, so we use that for our X and for our Y. But you don't have to use the vertex to do something, to do that. Does that make sense? So that was only the factored form version of it. We could have also used vertex form. Again, I would write out that vertex form. And so what's going to be H and K?
3 and -6.
Remember H and K, that's our vertex. What can I use for my X and for my Y?
I use the R2 for
So you could use R2 and the 0, or you can use R1 and the 0. Remember, if we're doing vertex form, we don't have to think about these as roots, we just need points. We just need an X and a Y to be able to substitute into that equation. So let's do the 5, so the y value is 0 equals, do we know what a is yet?
No.
No. What am I going to substitute in for x?
5.
5, just an x value of a point, any point, minus the h is 3 squared plus negative 6.
Wait, is that just minus 6?
So you can also write that as minus 6, right? And I would switch that to a minus 6. That's it. From there,
So,
right, but what am I going to do to solve?
parentheses first.
So parentheses first, so that's 2 squared minus 6.
Then you do your exponent.
Okay, so if you haven't noticed this, this isn't the only way to do this problem, I will say. But I personally am going to simplify before I start using inverses to solve. I'm going to simplify before I start using inverses to solve. And then another really good principle to pay attention to is start with whatever number and operation are furthest from your variable. So what's furthest from my variable a? The minus 6. So what do I need to do?
Add 6 to both sides.
Okay. I will say I have people other than Hudson in here, which Hudson, I'm glad you're talking, but one, let other people talk. Two, get involved in the conversation. The person who talks the most will learn the most. Notice how I've only done plus 6 on the right-hand side, because what am I trying to do?
I'm trying to isolate the variable.
Well, not just that. Yes, I'm trying to isolate the variable, but look more
You
plainly.
need to cancel out the negative 6 and the plus 6.
But what do you mean cancel it out? What am I trying to do? Think numerically, what am I trying to create?
0.
I want a 0. We want to pay attention to, it's not just canceling out, I'm trying to create zeros and I'm trying to create ones. When adding and subtracting, I'm creating a 0. Yes, AJ?
I thought what you do with one side of it equals one.
Oh yeah, I'm not done yet.
Oh,
You're 100% right. I'm just saying I've only added 6 to the right-hand side, and because one of the things that students miss, and I think most teachers miss, is I'm trying to create a 0. So if I add 6 to the right-hand side, that's changing the equation. I don't want to change the equation, I want something that's equivalent. So because I added 6 to the right-hand side, I also have to add 6 to the left-hand side. That understanding of the order of why I'm doing what I'm doing is important. I'm trying to create a 0 first and foremost. But because I changed the right-hand side, to balance it out and keep the equation equivalent, I have to add 6 to the left-hand side as well. That order matters. And so I know that you know at this point I would divide by 4. What's the other way to show
The
that?
reciprocal.
The reciprocal, so times.
divided by 4.
Notice that language, right? 1 divided by 4 is going to help you remember, okay, I'm just dividing by 4, right? It's the same thing, but using the reciprocal. And notice again, where did I put my times 1/4 first?
On
On the right side. Right next to the 4, because I'm trying to create a what this time around? A 1, right? Notice I'm not trying to create a 0 this time. 4 divided by 4 is 1. I'm trying to create that 1 over there. Don't just say cancel. I'm trying to create 0s and 1s. And because I multiply by 1/4 on the right-hand side, I have to multiply by 1/4 on the left-hand side to balance it, to keep the equation equivalent. And again, this is important because notice what's 1 times a? A. That's the whole point is, yes, I'm trying to isolate a, and I do that by creating 0s and 1s. I forgot to mention it here, but if I have a times 4 minus 0, what does that give me?
8 times 4.
A times 4, right? I'm creating that 0 because when I subtract 0, it doesn't change what I have to start with. When I do multiply a by 1, it leaves me with just a. And then 6 times 1 divided by 4, once again, gives me 3/2. Now I have my a. X is my input variable, minus 3 squared minus 6. Writing out your equation, the form, the vertex form, each time will help you focus your attention so you don't make mistakes. Write out that equation to get started. Okay, I need my A, I need my H, and I need my K. Write out that equation every time. It really helps build good foundations and make sure you don't make mistakes. What are your questions before we get started on the understanding check? Yes, sir.
Will you check off if we don't simplify
The fraction? I won't, but I will say for that fraction, you'll have a calculator. And if you put 6 times 1/4 in the calculator, it'll automatically make it 3 halves. Does that make sense? So like, it's a good habit to just go ahead and do that. If you don't have a calculator, sure, whatever. But if you have a calculator, it'll do it for you. Okay? All right. Let's clear our desk. Even of the calculator, we're going to start with a non-calculator portion. It's going to be short. There's 4 questions total. But I want to see that you understand. One thing I will point out about the calculators, it's easier to make sure it doesn't fall through the slats if you turn it perpendicular to the wires. Am I going to give them to you, or do you need to know them? Yes, you need to know all of them. Did you study it all, Alicia?
Not last night. Wait, are you recording?
Yes.
Why you got me saying this on video?
Well, that wasn't the point, but like,
No, for real. I watched the videos, but I ain't do it last night.
okay. So what I'm passing out right now is the non-calculator portion. I want to see that you know the features. Okay. I have made sure that all the numbers on this non-calculator portion work out nicely. If you run into an issue on a procedure of calculating a number, how much will that actually hurt you on my scoring?
A lot.
Very, very little. I need you to remember, listen, I want to see, pause and listen, I want to see that you understand this. Remember, if you look at that scoring rubric, there's the 4 section that says clear, consistent, and convincing evidence of understanding. That's meaning that you don't make any mistakes on your wording or on your procedures. You might just be either missing a little bit of detail or you legitimately crushed it and didn't miss a single thing. But the 3 and the 3+, that clear evidence of understanding, you can still make a procedural error, maybe the calculation part, and still get a 3 and a 3+. And those are strong scores to increase your grade for me. So don't sweat making a mistake on a calculation, right? Show me what you know. Like, everyone should hopefully know how to identify the vertex from standard form. At this point, we did a lot of practice with it yesterday. We should know how to find the vertex when we have factored form and vertex form. You may make a procedural mistake, but show me what you know. And do not forget what you always need to do with your answers. Justify them, okay? You need to justify your answers. I try to make sure there's plenty of space. You have 20 minutes maximum to work on this non-calculator portion. After that, you can finish before that, turn it in and get the calculator portion. After you turn in, or at the 20 minutes though, I'm going to cap you on the non-calculator portion, and then you'll have 10 minutes for the calculator portion. So 20 minutes for non-calculator, and then a maximum of 10 for the calculator, but if you do finish non-calculator early, you will have extra time on the calculator portion. Yes, Melvorian?
What if we don't finish?
Then I need to know that, and then I will give you feedback so that you can improve your understanding before the test. Okay? Remember, this is not your final grade, this is an understanding check. It will be your grade temporarily until we get to that test, but there's a total of 7 questions in 30 minutes. Let's get to work. Yes? Did I not give you? My bad. There you go. Oh, one thing as a quick reminder, there is one feature that you do not have to identify for 2 of the equations because you don't know how to yet.
Is it the wires?
I can't tell you that. You need to know it. but there's one feature on 2 of the equations that you do not have to calculate yet. Still show me what you know about that feature, and that'll help probably answer your question, Hudson. Okay? So you know something about every feature on there. more minutes at this point. Show me everything you can during that time.
You gonna knock around, bro? You gonna knock around before I'm writing?
But you didn't get it right, did you?
Right.
Guys, I don't know how you expect to be successful if you're not studying.
I need them.
No, you didn't.
Yes, I did. I told them about to do it.
I can't see.
You didn't study last night.
That's different.
It's not. Hey guys, talking's gotta stop. give y'all 3 more minutes to get as much as you can done. At that point, we will turn it in. Yes, this section you can use the calculator. That would be great evidence to have on there. I just think that would be some good evidence. Right? All right, let's turn that section in. Let's start the calculator portion. What? Guys, we've been on calculator. Let's come up here, let's turn that in. Let's get to the calculator portion. gonna give y'all 2 more minutes beyond that 10 to wrap up everything you've got. And I know that seems fast, but if you're not getting it at that time, you're probably just spinning your wheels and not being productive at that point. So 2 minutes, go. Okay. Put all your sheets together at the center of the group. I will come by and grab it. While we're getting set up, go ahead and get out your textbook and go to, I think it's lesson 5. Yes, lesson 5. It's on page, apparently I didn't write down what page it is. M1-79 maybe? Okay, M1-79. By the way, make sure your name's on this second sheet as well. Textbooks out, lesson 5, M1-79. Your work through this point is justification is work. Now, there's more that you might have been able to say, but like any work you're showing is part of your justification. Right. Hey guys, let's clarify something really quickly. Any work that you would be showing to get, hey, I'm talking, please listen, M1-79. Any work that you would be showing to get your equations is justification. You don't have to write every time. Justification means, and this is what I need y'all to understand, when I ask for justification, you're making a claim with every answer you put. So the final equation you have is a claim. How did you get to that answer? That's what justification is. And so it depends on the type of problem. If you're telling me that something is a linear function because I've given you a graph or given you an equation, you need to tell me how you know. If it's linear, oh, it has a constant additive rate of change, and this is where I see that, right? This equation is linear because it has the equation y equals mx plus b. Justification in that case would require words. A lot of the justification here would be your work, okay? So those are things to consider, and we'll talk about. And again, this is partially a learning thing, but let's get started with this lesson. So hear me very clearly on this. We are going to cover 3 different methods. We are seeing lots of 3s if you haven't noticed. There are 3 types of functions, which are quadratic, exponential, and linear. And I'll have that understanding check back to you tomorrow for sure. I will hopefully have this one back to you as well, and we'll talk about a few things that I'm noticing. There are 3 quadratic equations:
Vertex form.
vertex form,
Factor form.
factored form, and standard form. And then now we are looking at 3 methods to solve quadratic equations. And so it even has 2 bullet points right here, but this is to help us get here, right? So we are looking at how we can use, or actually how we can factor. Sorry, I'm going to play it on the back screen as well for those back there. We're going to look at how we can use factoring. We're going to talk about using vertex form and the quadratic formula, and we will hopefully get through those things. The goal is completely through by tomorrow at the end of class, but realistically sometime on Monday. We'll get some practice in next Tuesday, Wednesday time, and then we will be probably testing next Friday. Be aware of that and be planning for that. Okay, so here's lesson 5 called the root of the problem. And we're going to talk more about roots within this. And these learning objectives are exactly what we're going to do, although I will say you can cross off in the book this last learning goal. We will not be doing that one. It's a good learning goal. We only have so much time in a day, though. Tori, are you asking a question or are you eating something?
I'm eating.
Okay.